Section 2.2 deals with the derivative of the exponential function. Very simple. This is the simplest possible function when it comes to its derivative. Its derivative is e to the x. How come? Yep. So the derivative of e to the x is e to the x. Now, if we have a function that is e to another function, let's say g of x, then I have to use the chain rule. So e to a function, so I should also write here times x prime, but I don't, because x prime is 1. But g is a function. Its derivative most probably is not 1. So then when I differentiate e to a function prime, I get e to that function, of course, times the inner function prime, which means g prime of x. So please remember, this is the same formula actually. I should write times x prime, but I don't because it's 1. So e to a function prime is e to a function times the inner function prime. So I'm going to open on page 210, and I want us to choose problems to work on. Please contribute. Please ask questions. Please work together with me. It's the best way to remember these topics. So we want to differentiate, meaning we want to find the first derivative of any of these problems to practice from 1 to 24. So let's choose a couple, and then we can look at word problems, which is our target.
Can we do 16?
Yes, please. So 16 on page 210. Okay, so let's say, where are you, 16? Perfect. Excellent. Y equals the square root of e to the x plus 1. I saw students still change the square root of x into x to 1/2. I'm not saying it's wrong, but the easiest thing is to write this. This is fine. You can differentiate like that, but it's more cumbersome. If the index is anything else but 2, remember I said, yes, you have no choice. But this is the simplest one, so you shouldn't waste your time with it, but it's up to you. Both methods are acceptable. So let's review this. So when I have a function under the square root and I want to differentiate it, I'm using this procedure. It's 1 over 2 the square root of the function, but times the inner function prime. So this is a review of the chain rule applied to the square root. So when we want to differentiate this, we can write y prime, we can write dy over dx. Can anyone tell us what it is? What do you think? What should I write? It's okay if you're wrong.
1 over 2 the square root of x plus times x.
You mean e to the x plus 1? Good. Times?
Yeah.
Times e to the x. When we differentiate the inner function, we get e to the x. It's very simple. The derivative of e to the x is e to the x, and the derivative of 1 is 0. Good. Any questions on this problem, please? Is this okay? Is this okay?
Yes.
Perfect.
Yeah.
Good. Tell me if we need more. And if you say yes, let's choose.
Can we do number 18?
Yes. Let's look at number 18. And that's my page 2. And number 18 on the same page. 18, where are you? Yes. Y equals x e to negative 2x plus e to negative 2x plus x to the third. Perfect. Very good example. Good. So either write y prime or dy over dx. Good. So let's start with the first piece. What will you say? What is the first piece all about? What do I need to do with the first piece? What is it? How will I address it? I have to identify what it is first. So I know which procedure to apply. So what is this?
Product rule.
Matt, what did you say?
Product rule.
Exactly. That's all I wanted to hear. So this is a product. The first function prime is 1 plus x times e to negative 2x. Can anyone help with e to negative 2x prime? Here's the formula. Ready? We want to differentiate e to negative 2x.
Is it negative 2e?
Yes. So it's e to negative 2x multiplied by the inner function, which is negative 2. So we finish with this. Awesome. Plus, I reached this point. In the same way, can anyone differentiate e to negative x for us? They're not two pluses. I'm just indicating that something else follows. Look for it. Can anyone differentiate e to negative x for us? Anyone, please?
E to the negative x times x.
Times the inner function prime, which is negative 1. Okay? Yes, everyone? Plus, can anyone differentiate x to the third?
Three x squared.
Excellent. Good. So I'm going to try and organize it a little bit. E to negative 2x. Here I have negative 2x e to negative 2x. Here I have negative e to negative x plus 3x squared. And this is it. No one can do anything else to this. Carved in stone. Questions on this problem, or we move on to another?
We do one more like that.
Of course. Let's choose. So here they're asking us to look at the second derivative. So see if you want to work on the second derivative. Of course, this will be hairy, quite, because of the second derivative. So let's choose another. Anything you like, so we can move on to word problems.
Maybe 34.
Okay, so we want to look at 34. V of t, 34 is e raised to the cube root of t. How on earth they came up with that? It doesn't matter. Let's take a look. So first of all, I will rewrite it as e raised to t to which power? Because it's the cube root. Which power is the cube root?
-3.
1/3, right? So we said that any radical, let's say, the nth root of a to the mth power is a m over n. So any radical can be changed into an exponential notation as long as the exponent is a fraction. Good. So now we're ready to find the first derivative. E to a function prime is e to that function times the inner function prime, t to 1/3 prime. Can anyone help with t to 1/3 prime? This is not new. We know how to differentiate t to 1/3. Anyone wants to try, please?
Is it 3t
We bring down the power
1/3 t
and we subtract 1 from the power.
-2/3?
Exactly. This is it. Let me try to organize it a little bit. I'll put 1/3 in front. I will put e to t to 1/3 multiplied by t to -2/3. And now the second derivative is not going to be pleasant. So the second derivative, leave the 1/3 outside. We don't need it. The first function prime, I already have it here. We just differentiated this. It's all this. I'm going to copy it. 1/3 e to t to 1/3 times t to -2/3. The first function prime times the second function plus because it's a product, plus the first function which is 1/3 e to t to 1/3 times the second function prime. Can anyone differentiate this for us? T to -2/3. We bring down -2/3 and then t to which power?
-5/3.
Excellent. Thank you. -5/3. Now I'm going to try to, I don't know what I'm going to try to see what is going on in here. Okay, so still leave the 1/3 outside. I have 1/3. I copy e to t to 1/3 times, copy the base, add the exponents. -2/3 minus 2/3 is -4/3. Copy the base, add the exponents. Okay, now I have minus 2/9. 2/3 times 1/3. E to t to 1/3. And then times t to -5/3. I'm not going to factor anything. I'm just going to leave it alone. I could factor 1/3. I could factor this. And I could factor t to -5/3. Not important. That's fine. Okay. This was a lot of work because of the powers that are rational and so on and so forth. And then it changed into a product, so it complicated things. Okay. Is there anything else we would like to work on? Maybe you want to choose a ratio. I'd like to choose 23. So in 23, we have r of t equals t squared plus 2t and e to t squared. They're big on e to a power that has another power. Okay, so what are we going to do here? What is it, and what are we going to apply? So we know which rule to apply here. Anyone, please?
Quotient.
Excellent. So r prime of t. I know I have to square this. Remember when I square e to t squared squared, I copy the base, and what happens to the exponents? Anyone, please? Anyone, please? We copy the base, and what happens to the exponents?
Would you add them?
We add them when we multiply. So if I have a to m times a to n, I do add them, m plus n. But when we raise to a power, what do we do with the exponents? Anyone else, please? Quinn, what do you think? Devin, what do you think?
You multiply.
Thank you so much. So this is indeed 2t squared. Excellent, thank you. So now we use the quotient rule. The top prime, 2t plus 2, times the denominator, minus the top times the denominator prime. Can anyone differentiate this for us? E to t squared prime. What do we get? Please try. Anybody? E to
T.
yes.
T squared.
So e to t squared times the inner function 2t. Indeed. Okay. I'm going to try to simplify it a little bit and see if it's possible. So I am going to factor out the common factor, which is this. Is present in both terms. So I'm going to put e to t squared outside. Because this is e to t squared, as you know, squared, and I will be able to simplify one of them. Let's see what is left. The 2t plus 2. Now careful. There is a 2t. There is a 2t that needs to be distributed here, but also the negative sign is there. So 2t times t squared is 2t cubed with minus. 2t times 2t is 4t squared with minus. Okay, so I was able to simplify it a little bit. I will rearrange it in descending order to clean it up nicely. Negative 2t to the third minus 4t squared plus 2t plus 2 over e to t squared. I should have factored out the 2, but this is it. There is nothing else to it. Good. So I think we got the idea on how to differentiate e to the x or to t, doesn't matter, and also e to a function. So now I think we should look at word problems. Now I want to explain what the concept of marginal cost, marginal profit, marginal revenue before we choose a problem. So In economics, let me see my video. Okay, let me stop.